Find the remaining roots if you are given certain roots already, right? So here's a polynomial equation, 2x cubed minus 5x squared minus 4x plus 3. The root given is x minus 3, right? So this isn't necessary for this question, but if we're given a root at x equals 3, that's a solution, right? Remember, roots are solutions. And if it's a root, which is also a solution, that also means, this is the unnecessary part, that x minus 3 is a factor of the given polynomial. So what we want to do is, in order to find the other roots of this polynomial, there's 3 total because the degree of this polynomial is 3. We have one of them right here. Right? So I need to find the other 2. In order to find the other 2, what you're going to do is try to factor this completely, right? So it's a division problem at first, right? So we're going to start with coefficients, standard form. There are no placeholders necessary here. And I'm going to start by putting root 3 here, and I'm going to work it. Now, one thing I know for sure here is that this will definitely be a 0 because it's telling me that x equals 3 is a root. And if it's a root, I'm going to get a remainder of 0 down here, right? So let's go through the process. 2 plus 0 is 2, multiply 6, add 1, multiply 3, add negative 1, multiply negative 3. So we knew that that was going to happen. What we need from this is, we need the quotient, right? This is 2x squared plus 1x minus 1. That's the quotient, remainder 0. So just to help you process this, what we're doing is we're taking this polynomial and we're factoring it, right? So one of the factors we knew existed from the beginning was x minus 3 because it gave us a root at x equals 3. Right? The other factor here is 2x squared plus 1x minus 1. That's my other factor. Right? So this is the factored form of this equation right now. Now, is it completely factored? We don't know yet. Right? What we want to do is take this blue factor and see if we can factor it, right? So I believe the blue factors, and if it doesn't factor, that just means it's a prime factor, and you would need to move to quadratic formula or complete the square to find the remaining roots. But right now we're just looking for the roots of this, and let's see if I think it does factor, so let's check it out. Right? Factoring is always going to be your easiest approach here. Here's the existing one, x minus 3. Right? We already knew that, though. So this is going to become 2x and x. This will be a plus 1 and a minus 1. Now, it pays to double check that your factors actually produce the original blue factor here. Just go back and double check it to make sure it does. This one does. So from here, it's 0 product property for the blue factors, right? 2x minus 1 equals 0, x plus 1 equals 0, solve, x is a half, solve, x is negative 1, and we already knew that this one was x is 3 because it was given to us, right? So the polynomial equation given to us was a degree 3. We just found 3 roots, 3 solutions, right? And then we're going to list our solutions in a set. So negative 1, comma 1/2, comma 3. And that is it for this problem.